Hey everybody, this is a video that is EOC review on checking for linearity. We're going to start with the definition. So we're looking at a linear function, sometimes referred to as a linear equation. A linear function has an equation with x raised to the first power, which results in the graph of a straight line when plotted in the Cartesian plane. The Cartesian plane is just the normal xy coordinates that's named after a guy named René Descartes, a mathematician and philosopher. So we're going to learn how you can tell if a graph makes a straight line, if an equation makes a straight line, and if a table makes a straight line. Here we go. All right, so pretty easy. When we're looking at a graph, we're going to know we have a straight line if the points make a straight line. It's pretty straightforward. Now, not all graphs make straight lines, so we might be looking at something like these. And we can point out for different reasons why each one of these is not a linear function. I put the equations with each of these graphs so you can see that sometimes they look similar and some of them look different, but they can each make a linear graph, and we'll see more on that in a couple slides. Back to the non-linear graphs. We'll learn more about these other three forms later, the quadratic, the exponential, and the absolute value function. So the red one is called quadratic. We can see its equation has an x squared in it, and we can see that it has a vertex at 0, -2, and that's where the graph turns around and goes from decreasing to increasing. Linear functions are always increasing or decreasing. They never change directions. This exponential function at the top right has x in the exponent, and we can tell it's not linear because, well, the pattern doesn't stay the same. Here it goes up 1 over 1, but then here it goes up 6 over 2, and that's just not the same pattern. Contrast that with this green graph. Even if we're looking at a different amount, so down 2 over 1, or down 6 over 3, that's going to end up being the same type of change. This last one is this absolute value function. It looks linear, but we can see that right here it has a vertex at -3, 0, where it changes directions from decreasing to increasing. So all nonlinear. Okay, if you're looking at an equation, you can group these into two baskets, either linear or nonlinear. The first one that you see, y equals 3x plus 4, that has x raised to the first power. The second one is given as f of x, which, remember, is just a little bit fancier of a way of saying y equals. You'll learn more in Algebra 1 and Algebra 2 why that's beneficial, but it's more of the same thing. Now this next one, y equals 2x plus 5y minus x plus 7, certainly seems complicated, but we could combine like terms and simplify that down, and it would still simplify down to y equals some number of x's plus some constant. The next one, y minus 5 equals 2 times x plus 3, is a little confusing because there's parentheses and there's a constant on the other side of the equation. But if you think about the x in parentheses, that's just raised to the first power. Same thing in this final equation. Even though the x and y are on the same side of the equation, the x is only raised to the first power. Things can be nonlinear for a whole host of reasons. For example, x might be squared or raised to some other power aside from 1. One of the variables might be inside an absolute value. X might be in the exponent. We might have some other type of function altogether, like this one, which is y equals 2 times the cosine of x. We might have x in the denominator. We might have x in a square root. We might have x raised to a fractional power. All of those are going to be nonlinear. There are three linear forms you should familiarize yourself with. One is slope-intercept form. Some people refer to that as SIF. That's when you have y equals mx plus b. For this particular one, remember the slope is 3 because that's the coefficient of the x variable, and the y-intercept is 0, 4. The next one is called standard form. X and y are on one side, and the constant term is on the other. Normally what we would do is we would turn that into a y equals mx plus b equation. That's one way of approaching that. The final one is called point-slope form. As the name implies, it tells us a point and the slope. Here the slope is 2, because that would be the coefficient of x, and the point would be -3, +5. It's the opposite of the numbers being added or subtracted to the variables. Okay, finally, if you have a table and you want to decide if it's linear, what you're going to have to do is you are going to have to look at how the table changes, both in terms of the output and the input. So how do I get from 9 to -5? I add 4. How do I get from -5 to -3? I add 2. If you're stuck on how to do that, and you need to use the help of a calculator, you would say, okay, what is 5 minus 3? It's 2. What is 9 minus 5? It's 4. We're going to do that for both sides of the table. And then we're going to look at the ratios. What I mean by that is 4 over 2, 2 over 1, 6 over 3, 2 over 1, 4 over 2, and 4 over 2. If every single one of those is the same, then you have what's called a linear table. If you're wondering as to why you do 4 over 2 instead of 2 over 4, remember that we compute slope using y2 minus y1 over x2 minus x1, or change in y over change in x, or rise over run. Now, when I'm looking at this next table, I start computing the changes in y and the changes in x, and I notice right away I go down 22, then down 5, then up 9. This table is changing directions. It's going down 22, then down 5, then up 9. So I could immediately say that's nonlinear because linear things don't change directions. Also, I can look at those ratios, and I could say -22 over 2 and -5 over 1 are not the same thing. Therefore, this is going to be a non-linear table. I don't need to check the rest of the ratios because as soon as any two of them don't work, I know this is nonlinear. All right, so summary there. 3 different ways to check for linearity from a graph, from an equation, and from a table, with a little bonus snippet on the 3 different linear forms that we use the most often. Thanks for watching and hope that helps you study for your exams.